Greetings, Mr. Sutton here with the Pre-Cal Honors 9-4 Extra Practice Number 2 solutions on algebraic limits of piecewise functions. On this problem, we're trying to find the limit as x approaches 0 of this piecewise function. Since 0 is the border value of this piecewise function, we need to consider both the left and the right side limits. So for the left side limit as x approaches 0, we're using this less than 0 rule here. So just plugging 0 into this first rule, we have 0 over 2 minus 3, which comes out to negative 3. And now for the right-sided limit at 0, using the second rule, we have 2 times 0 minus 3, which also comes out to negative 3. Since the left and the right limits are both the same, the two-sided limit is also going to be negative 3. For this problem, we're trying to find the limit as x approaches negative 4 for this piecewise function. Since negative 4 is a border value, we have to take the left and the right-sided limits at negative 4. So for the left-sided limit at negative 4 for this thing, we're using the rule where x is less than negative 4. So plugging negative 4 into this first rule. So all these x's, we'll just replace those with negative 4's. Using a little PEMDAS here, this first thing is going to be negative 16. Then we have plus 16, so that just cancels out. And then minus 3, so negative 3 is our left side limit. Now for the right side limit at negative 4, we're using the second rule where x values are greater than negative 4. So we have negative 2 times negative 4 minus 2. That's going to be 8 minus 2, which is 6. Since the left and the right-sided limits are not the same, the overall two-sided limit does not exist. For this problem, I'm trying to find the limit as x approaches negative 2 for this piecewise function. Since negative 2 is the border value here, I need to find the left and the right-sided limits at negative 2. For the left-sided limit, we're using the rule where x is less than negative 2, so that automatically returns negative 3 as the output, no matter what you plug in. For the right-sided limit at negative 2, we're using this second rule, so that's going to be negative 2 over 2 minus 2. So negative 1 minus 2 comes out to negative 3. And since the left and the right side limits give us the same answer, that means the two-sided limit is going to be that answer. So negative 3 for the overall two-sided limit as x approaches negative 2. For this one, I'm trying to figure out the limit as x approaches negative 5 for this piecewise function. Since negative 5 is a border value, we're going to use the left and the right-sided limits and compare those. So left-sided limit at negative 5, that's going to be negative 5 plugged into this before rule here. So that's negative 5 squared minus 8 times negative 5 minus 16. Using a little PEMDAS, this is going to be negative 25 plus 40 is going to be, let's see here, 15. And then minus 16 gives us negative 1 overall. For this second rule now, using the right-sided limit at negative 5, we're automatically just going to get back negative 4. Since that doesn't match the left-sided limit, our overall limit at negative 5 does not exist. For this problem, we're trying to find the limit as x approaches 3 for this piecewise function. Since 3 is the border value between these two rules, that means we have to find the left and the right side limit and make sure they're the same thing. So using the left-sided limit at 3, that's going to be using this less than 3 rule. So we have minus 3 halves minus 1 half. Well, this is really negative 4 halves, which is negative 2. And now taking the right-sided limit at 3, that's using this greater than 3 rule. That's going to be 2 times 3 minus 13, which is not negative 2, it's negative 7. Since these limits don't match, that means the overall two-sided limit does not exist. For this problem, we're trying to find the limit as x approaches 1 for this piecewise function. Since 1 is a border value, we have to look at the left and the right-sided limits here. So for the left-sided limit as x approaches 1, we're using this x less than 1 rule. So negative 1 minus 1, which comes out to negative 2. And then for the right-sided limit at 1, that's going to be using this greater than 1 rule. So we have negative 1 squared plus 4 times 1 minus 5. So this is negative 1 plus 4, which comes out to 3, minus 5 comes out to negative 2. Since the left and the right-sided limits are the same thing, that means the overall two-sided limit will also be negative 2. On this problem, I'm trying to find the limit as x approaches 2 from the left side for this absolute value function. So I'm going to make my life a little easier by redefining this whole thing as f of x, just so I can quickly refer to it. And since I have absolute value, I can break this up into a piecewise function. Our border value is going to be whatever zeroes out the absolute value, because that's when the behavior of absolute value changes a little bit. So the x value that would zero this out, that would be 2, because if you have negative 2 plus 2, that would be 0. So we have a rule for x less than 2 and a rule for x greater than 2. Let's say x is less than 2, like 1 for example. Well, negative 1 plus 2 is a positive number. If we're getting positives inside here, absolute value doesn't really have to do anything. So I can rewrite this as just negative x plus 2 with no absolute value for that rule. But now let's say that x is greater than 2. So for example, let's say we had 3. Well, negative 3 plus 2 would give us a negative. So if I'm getting negatives inside here, absolute value has to multiply all of that by negative 1 in order to force it to be positive. So I'm going to rewrite this as a negative parentheses negative x plus 2. And that's going to take care of forcing this stuff to come out positive. All right, now I can go a little bit further here. Both of these rules, I can factor a 3 out of the numerator. And I guess I could factor a negative 3, but the reason I'm taking out a positive 3 is I can now cancel out this negative x plus 2 in both of these cases. So we end up with positive 3 for this rule and negative 3 for this rule down here. The reason we had to go to the trouble of doing that is if I had just plugged 2 in right away, I would have gotten 0 over 0. But now I'm not going to have that issue. So now taking a look at the limit as I approach 2 from the left side, that's going to be using this rule where x is less than 2. So that just gives us 3. For this problem, I'm finding the limit as x approaches 2 for this absolute value fraction monstrosity. So I'm going to start by letting this whole thing equal f of x just so I can quickly refer to it. And since we have the absolute value, we can turn this into a piecewise function. The border value is going to be whatever zeroes out the absolute value, because that's when the behavior of absolute value changes, positive versus negative inputs to it. So I have a rule for where x is less than 2 and a rule for x greater than 2. I don't have a rule for x exactly 2 because that would just give us 0 over 0. All right, so if x is less than 2, for example, 1. 1 minus 2 would give me a negative number. So to force things to be positive, absolute value has to multiply all that by negative 1. So I'm going to rewrite this as negative parentheses x minus 2. So that's going to force all those to come out positive. Now, if x is a number greater than 2, for example, 3, well, 3 minus 2, that's going to give us a positive. So if this stuff is already coming out positive, I don't need the absolute value at all. So I can just write x minus 2 over x minus 2. So at this point, I'm going to start thinking about what I need to do to find this limit. Since 2 is the border value, I would need to find the left and the right side limits. But if I try plugging 2 into either of these rules, I'm going to get 0 over 0. So first I'm going to cancel out some common factors here. This first rule, this is really just negative 1 if we cancel out these x minus 2's. And this bottom rule here is going to be positive 1. So now taking the left and the right side limits, left side limit is just this before 2 rule, so negative 1. The right side limit at 2 is going to be the after rule, so that's positive 1. And since these limits do not match up, that means the overall two-sided limit at 2 does not exist. For this one, we have this f function here, and we're trying to find the left side limit as x approaches 1. So for that, we have to use the before 1 rule. Since 1 is a border value, we have to pick between these rules. So using this before 1 rule, we've got just 1 plus 3. And that's just going to be 4, which gives us answer choice B.